Close your eyes and imagine a sphere of light so steady you could measure time by it. This is our sun, the warm heart around which everything in our small corner of the galaxy turns. It is not a distant lamp, but a living furnace, an ocean of boiling gas whose gravity keeps the whole family of planets and small bodies in place. The sun is vast. More than 1,000,000 Earths could fit inside it. Its mass dominates the system. Over 99% of everything in the solar system hangs to that gravitational note. From that heavy center, fragile life on Earth pulses through the cycles of day and night, seasons and storms. The sun is not a static thing. It breathes in magnetic cycles, winds outward charged particles, and occasionally flings off the surface in a bright, sudden burst. These events, solar flares and coronal mass ejections, are reminders that the sun is a dynamic star with moods that ripple outward. Those ripples sculpt the space near Earth. Auroras, radio blackouts, and the faint push that shapes comet tails. Everything in the solar system is a relationship with the sun. Planets trace paths of trust and tension, orbital lanes balanced by gravity and motion. Comets arrive from the farness, whispering of the system's cold reservoirs. Asteroids cluster in belts, archives of ancient rock. The sun's light makes the visible world color, warmth, shadow, and its gravity shapes the invisible web. Imagine standing on a quiet beach and watching waves come and go. The sun is that steady tide, more patient than all of us, shaping weather and habitability by how it brightens and dims over ages. It is at once a furnace, a clock, and a gentle architect. The solar system is a house built around it, and the rooms, planets, belts, moons, are shaped by its steady pull. Now breathe in that sense of scale. The sun is our center, our rhythm. The rest of the system moves in measured motion around it, a slow choreography written in gravity and light. In the hush of a midnight sky, when you can see the pale glow of planets, remember that all of it is framed by that warm, enduring heart. The solar system's inner neighborhood is a close, bright courtyard of rocky worlds. These are the planets that live near the sun, each shaped by heat, stone, and the particular way gravity and time have pressed their faces. First is Mercury, small and battered, skimming closest to the sun. It is a place of extremes. Days scorchingly hot, nights frozen. Mercury's surface is a mosaic of impact scars and smooth plains, a record of countless collisions in the early years of the system. Venus, the next door, is a sister in size to Earth, but a world of oppressive heat and pressure. Its thick atmosphere is filled with carbon dioxide and clouds of sulfuric acid. The surface is shrouded and violent. Venus shows how similar beginnings can diverge. Where greenhouse conditions run away, the planet can become a pressure cooker of clouds and lightning. The thought of a sunset on Venus is unlike any earthly twilight. Orange-red light filtered through thick, choking skies. Still, Venus holds lessons about atmospheric behavior and planetary evolution. Earth sits third, small and delicate in its golden band of habitability. The presence of liquid water, a protective atmosphere, and a magnetic field that shields life from harsh particles make it unique in this neighborhood. Earth's climate and biosphere are woven with the planet's geological rhythms, mountains, oceans, life's cycles, all responding to a narrow range of conditions kept by the sun's steady hand and by internal processes that recycle rock and gas. Then comes Mars, the red desert we have always loved to imagine as a second home. Its rusty plains and wide canyons bear the traces of ancient water. Riverbeds and deltas speak of a wetter past. Today, Mars is thin and cold, with seasons and dust storms that stretch across continents. But its subsurface ice and its geologic memory offer a promise. A planet that once had rivers and may still hide watery refuges underground. Mars presses a quiet question into our imagination. Can a world once wet become a place to live again? These inner planets live under the sun's close influence, warmed, weathered, shaped. Their stories are intimate and instructive. Mercury's scars are lessons in impact and resilience. Venus reminds us of the dangers of runaway atmospheres. Earth is our fragile, breathing home. Mars is a museum and a possibility. Together, these worlds form the warm courtyard of our system, the place where we first learned to be planetary beings. Beyond the rocky inner courtyard, the solar system opens into a grand and quieter garden of gas and ice. Here, the giant planets hold court, enormous, majestic, slow to change, and rich with moons and rings. They are the heavyweights that shape the architecture of the system. Jupiter is first among giants, a planet of gas, primarily hydrogen and helium, massive enough to bend wild paths and shepherd swarms of smaller bodies. It is a planet of belts and zones, of turbulent storms, the largest of which, the Great Red Spot, has persisted for centuries. Jupiter's gravity plays a guardian role. It seizes and scatters comets, shapes asteroid orbits, and creates resonant structures that define gaps and clusters. Its many moons range from small rocky bodies to large worlds with oceans beneath icy shells. Europa, with its cracked ice and possible subsurface ocean, is a whisper of worlds that could hide habitats beneath frozen crusts. Saturn follows with its own delicate drama, a realm of broad, spectacular rings glittering with icy particles. Saturn's rings are intricate and ephemeral on cosmic timescales, their graceful bands a contrast to the deep mass of the planet. Saturn's moons, too, are diverse. Titan boasts a thick nitrogen atmosphere and rivers of methane, a world almost like a primordial Earth. Enceladus sprays plumes of water from its south pole, offering direct access to subsurface liquid reservoirs. These giants are laboratories of extremes, deep atmospheres, magnetic fields, and moons that may hold the keys to chemical complexity beyond Earth. The giants are not only spectacular, they also influence life's safety on the inner neighborhood. Their gravity can swing comets into safe outer orbits or fling them inward. They shape the belt of asteroids and the population of long-period comets. Their moons expand the idea of habitability, that life might exist not only on rocky planets, but under ice shells warmed by tides and chemistry. To stand before Jupiter and Saturn in the mind's eye is to see the solar system's weight and generosity, enormous worlds that govern motion, cradle smaller satellites, and show that habitability can wear many faces. The giants remind us the solar system is layered, a place where different materials and scales weave a complex and living architecture. At the distant edge of the planetary family, where sunlight thins and seasons stretch longer, lie the ice giants, Uranus and Neptune. They are cooler, slower, and somehow more serene than the inner giants, yet their presence carries quiet dynamism. Uranus tilts dramatically. Its axis nearly rolls around the sun, producing seasons that last decades and sunlight that plays like a slow pendulum across its atmosphere. This peculiar tilt gives Uranus an oddness that scientists still puzzle over. Perhaps a collision in its youth knocked it onto its side. Uranus is composed of water, ammonia, and methane ices mixed with hydrogen and helium, resulting in a blue-green hue where methane absorbs red light. Its faint rings and many moons are scattered like a calm, distant archipelago. Neptune lives slightly further out and appears as a deeper, vibrant blue. It hides fierce winds in its thin, cold atmosphere, the fastest in the solar system. Neptune's moon Triton, likely a captured object from the Kuiper Belt, shows geysers and ancient geology, offering beauty and curiosity at the system's edge. These ice giants contain different proportions of heavier elements and ices than Jupiter and Saturn, and their interior dynamics, heat flow, magnetic fields, and weather are active in ways that surprise us. Their distances mean that sunlight is weak, yet internal heat and complex chemistry create weather and storm systems. Their presence helps round out the solar system's palette. Rocky cores inside, swaths of gas and ice, and distant winds shaping clouds in twilight. The outer planets remind us that the system's variety grows with distance. Materials that could not condense closer to the sun, ices and volatiles, form massive worlds here. These planets point outward to darker realms, belts of icy rubble, scattered objects, and the deep, seldom touched reservoirs of comets that visit us only briefly. To meet Uranus and Neptune in thought is to feel the solar system's far breath, cold, ancient, and quietly alive. Between and beyond the planets lies a host of smaller worlds, rocky and icy stones, each with a memory of the system's formation. These minor members are not minor in meaning. They are literal building blocks and time capsules, preserving chemistry and history. The asteroid belt between Mars and Jupiter is a rocky workshop of fragments and planetesimals. Ceres, the largest object there, is a dwarf planet with evidence of past water activity. The belt's varied inhabitants, from metallic to carbon-rich, tell the story of early collisions and accretion. These rocks carry clues to how the inner planets formed, melted, and differentiated. Further out sits the Kuiper Belt, a sprawling disk of icy bodies beyond Neptune. Here dwell dwarf planets like Pluto, Haumea, Makemake, and Eris. These trans-Neptunian objects are cold and distant, preserving ices and organics that predate planetary formation. Pluto's landscape, measured by the New Horizons mission, revealed mountains of water ice, nitrogen plains, and a complexity that surprised everyone. The Kuiper Belt is also the origin of many short-period comets, objects perturbed inward by giant planet interactions or collisions. Beyond even the Kuiper Belt lies the hypothetical Oort cloud, a spherical reservoir of icy bodies so distant that their orbits are measured in tens of thousands of years. Occasionally, a passing star or subtle gravitational tug sends one of these comets falling inward, gracing inner skies with long, bright tails. Comets are not mere spectacles. They deliver volatile chemistry and maybe even prebiotic molecules to planets, seeding chemistry that can be foundational to life. Each small body holds a story, a collisional past, a preserved chemistry, a moon, or even a ring. They are the solar system's archive boxes, compact, ancient, and full of evidence about how planets grew. Visiting these worlds with probes has taught us that complexity exists at every scale. Even the tiniest rock can change a theory. So when you gaze at a shooting star or follow a comet's arc, remember you are watching a fragment of deep time, a messenger from the edges that reveals the system's slow and patient history. It is easy to think of the solar system as fixed and finished, but its origin is a story of motion, collision, and gradual gathering. From a cold cloud of gas and dust, a nebula, our sun and its companions slowly emerged. Imagine a quiet, massive cloud thrown into gentle collapse, perhaps by a shock wave from a nearby supernova or by internal instability. Angular momentum nudged the collapsing cloud into a spinning disk. That disk, the protoplanetary disk, concentrated most of the mass in the center where the sun ignited. Farther out, dust grains stuck together into pebbles, then into kilometer-scale planetesimals. Under gravity, these clumped into embryos and then planets. This nebular picture, the solar nebular hypothesis, explains why planets lie roughly in the same plane and orbit in the same direction, and why rocky planets formed near the sun, while icy giants formed further out. But the story is neither tidy nor deterministic. Collisions and migration played roles. Planetary orbits shifted. Some bodies were ejected into distant space, and giant planets may have moved a little from their birthplaces, scattering other material as they migrated. The early system was a violent workshop where chance and physics combined to produce the order we now see. Meteorites brought to Earth provide direct samples of this era. Their isotopic fingerprints tell of early heating, differentiation, and chemical gradients across the disk. They are fragments of worlds that never quite formed, or of the early tectonic stirring of embryos. The last stages of the formation, a late heavy bombardment and subsequent calm, left marks on planetary surfaces, craters, basins, and the layered tales of geology. When you look at the moon's pockmarked face, you are reading a page from this dramatic epoch, a world that preserves a record because it lacks plate tectonics and erosion to rewrite history. The birth of the solar system is a slow poem in gravity and chemistry. Dust meeting dust, heat igniting a star, oceans and atmospheres foreshadowed by gentle chemistry. It is a reminder that the present is always a product of patient, sometimes violent, pasts. If the solar system is a tapestry, gravity is the thread, and the sun's influence is the loom's slow spin. Gravity binds planets to orbits, shapes moons, and governs collisions. Yet other invisible forces also shape the environment. Magnetic fields and the solar wind work like weather across space. The sun's magnetic field extends through the heliosphere, carried outward by the solar wind, a steady flow of charged particles. This wind sculpts planetary magnetospheres, brushes comet tails, and creates the heliospheric bubble that shields the system from interstellar particles to some extent. When the sun's activity ramps up, charged storms cross the system, lighting auroras on Earth and stirring plasma around planetary magnetospheres. Planets with internal dynamos, like Earth and Jupiter, generate protective magnetic shields. These fields not only create auroral spectacles, but also protect atmospheres from erosion by the solar wind. Venus and Mars, with weak or absent global magnetic shields, have different fates. Venus's thick atmosphere and Mars's fragile one illustrate how magnetic protection and atmospheric chemistry interact over eons. Gravity and magnetism also create resonances and shepherding behaviors. Moons hold rings in place. Gaps in belts appear where orbital resonances clear paths, and Trojan asteroids park in stable Lagrange points near giant planets. These unseen rules of motion create structure and long-term stability, even as small perturbations slowly change orbits over millions of years. Space is not empty. It is threaded with fields and winds. These invisible forces shape the conditions for atmospheres, climates, and the gentle interplay of particles that may, in tiny ways, nudge planetary histories. Finally, we come home to why this gentle tour matters. The solar system is not merely a backdrop for human life. It is the context of our existence. It is the source of the materials we mine, the targets of our curiosity, and the reservoir of environments that test our ideas of habitability. Studying the solar system is a form of self-reflection. By learning how planets form, evolve, and sometimes host conditions for chemistry and life, we learn about Earth's fragility and rarity. We see how small changes in atmosphere, magnetic field, or orbital distance can mean the difference between ice, ocean, and inferno. We learn humility. The solar system is also a place of practical hope. Asteroids and planetary resources offer potential raw materials. The Moon and Mars could be stepping stones for deeper exploration. Icy moons may hide oceans that teach us about life's chemistry beyond the Earth. Each mission, a probe that flies, an orbiter that maps, a lander that samples, is a small, careful step in a long human enterprise. And beyond utility, there is poetry. On clear nights, thinking about planets and comets and the sun's steady gaze invites a calm awe. The solar system asks us to slow down, to contemplate time scales longer than a human life, and to feel our place in a greater story. It offers a lullaby of distance and connection. We are small, but we belong to a system of magnificent complexity and quiet rules. As this story winds to a close, breathe slowly and imagine the solar system as a gentle garden, the sun at its heart, rocky courtyards, gas gardens, icy expanses, and countless small treasures. Each world is a different room in a house that we are learning to know. In the hush between stars, there is comfort. Gravity keeps the planets turning, the sun keeps the clock, and we, who look up with curiosity and care, keep learning how to coexist within that patient design. Good night. Let the slow turning of the solar system ease you into a quiet, restful space. Remember the gentle, invisible threads that bind us to one another and to the star that warms our days. The cosmos moves on, steady and kind, and for a while you rest within its rhythm.